Bayes law in data science. Hi, I am M. Asif Hussain from KnowHow Academy. What are we going to learn in this video? We are going to see what is Bayes law, formula of Bayes law with some practical examples. So before directly telling into the what is the Bayes law and all, let me just give you some recap of the formula of probabilities that we have learned in our recent videos. So here, let me consider two events A and B. So what is the conditional probability if we consider probability of A given B? So the formula for this one is A intersection B divided by probability of B. So this is the general conditional probability formula that we have seen in our recent videos. Now the same conditional probability formula, if I would like to talk to you in the form of multiplication rule. So in the multiplication rule, what happens? What happens is that probability of A intersection B equals to probability of B given A into probability of A. So when I am telling that the probability of A intersection B is this one, then obviously this can be replaced in this position. Am I right? So for this, what we will write here? Probability of B given A into probability of A divided by in the denominator we have probability of B. So we get probability of B. So this is our Bayes law. So what exactly it is telling? It is telling that the conditional probability of getting A given B, it is equal to the following fraction that we have considered. The conditional probability of getting B given A times the probability of A. It is divided by the probability of B. This is called the Bayes law. It allows us to find out the relationship between two different conditional probabilities of two events, which we have A is one event and B is another event. So let me recap this one. It allows us to find the relationship between the two different conditional probabilities of two events that we have considered. Let me give you some real-time example where you can understand this relationship between two different conditional probabilities. Rather than explaining it to you in a mathematical formula, let me explain it to you in a general real-time example. Let me walk you through the medical research. Okay, I know that many of you might not be aware of different medical practitioners and so on. So, but it is very general that we know that many of the people, they have diabetes and many people, they have BP, which is blood pressure. So let us consider the relationship between these two. Many people nowadays, okay, they have diabetes, okay, though they are children, elders, old age people and so on. And many people, they also have blood pressures, diabetes and blood pressures, okay. Now let us consider the probability. Those who have diabetes, it is not compulsory that they should have a blood pressure. Or those who have blood pressure, it is not compulsory to have a diabetes. Or few people might have both diabetes and blood pressure. Am I right? BP. So now what I mean to say here is that, so if I tell you that people with diabetes, okay, and people with blood pressure, all right, people with blood pressure. Now here the point is that people with this blood pressure, okay, and this diabetes, okay, if they are 67%, let us consider 67%. Now let me consider the probability of same diabetes, okay, given BP, it is 41%. Let us consider 41%. So obviously 67% is greater than this 41%. Am I right? Okay. So what's happening here is that 67% people who have diabetes, it is not likely that they have blood pressure. But 41% people who have blood pressure may have or may not have diabetes. So I'm talking about the relationship between those two. Okay. And if you talk to the real-time scenario, many people you might have heard that, if you get BP, if you take more stress and all, yeah, you might lead to get a diabetes also. But if you have huge diabetes, you might get the blood pressure also. This is a common relationship that we all know in the form of a medical research. Now, leave this medical. Let me give you some another example of a business. Let us understand a small business perspective. So here, in the form of a business perspective, let me give you one small example that I have started one company. You all have planned for a startup and you have initiated a startup company. So let us consider some XYZ startup company. Okay, so in this XYZ startup company, you would like to hire the employees. Now, what kind of employees you would like to choose? You would like to choose recently passed out graduates. They are from technical background. Though they are not from any technical background, you would like to hire some college graduates. Okay, some college graduates. So now, recently completed college graduates, when I'm talking about, yes, they might be freshers, or they might be expert in academics, or they might have some sort of experience. So now let us consider people with experience and people with a high academic record. They have an excellent academics. Okay. So now what's happening between these two? So now let us consider that you have given an advertisement that you want to hire some employees and you have got some around 200 applications. Okay. You have got some 200 applicants. You have got resumes of those 200 people. So now if we consider out of these 200 people, applicants, those whom you have received the resumes, out of that, let us consider the probability of the people who have a good academic record or 60%, and probability of people who have an experience or 45%. Now let us consider another probability. The probability of people who have the good academics given experience as well. So we have 50%. Now the interesting factor is people of a good experience, having academics are how many? So for this kind of real-time example problems, we use the Bayes law. Many people call it as Bayes theorem. Many people will call it as Bayes rule. So now let us consider the same with a Bayes rule. So what is this Bayes rule? Let us consider. So the same thing, if you like to consider the people with an experience, given the academics or having academics equal to, that's what we would like to find out. Am I right? So people of good academics with less experience into people with an probability of experience divided by probability of academics. So for this, the formula, if we consider what is P of academics, then we have 0.5 50% into 0.45, this one, divided by probability of only academics, which is 60%, 0.6, which is 0.375. So my dear viewers, if we see here, the probability of the experienced candidates given academics are how many? 0.375, and the probability of high academics but less experience, okay, we have 0.5. So obviously 0.375 is less than 0.5. So the ideal candidate is someone who has experience, but someone who scored well in academics as well. Okay, so this is a general understanding of how we use the Bayes theorem in the real time that we have any sort of situation that we encounter when we are doing projects in data science. All right, so let me give you one interesting question. Okay, let me give you one question and let me see who can give the correct answer for this Bayes theorem. Okay, the question is that a very simple question. So the probability of A given B, you need to find out when you have knowing that the probability of B given A is 0.6 and the probability of A is 0.4 and the probability of B is 0.3. Okay, now you need to find out what is the probability of A given B using the Bayes theorem. Okay, So I hope you have understood the Bayes theorem formula. Using the same formula, try to calculate this with the given values and get the solution. Comment that in the comment section. So thank you for choosing KnowHow Academy as your source for IT knowledge. We are always here to help you to navigate the tech world. If you have any questions, do not hesitate to reach out. It's been a pleasure sharing this information with you. Stay curious and keep learning.